I'm Anil Kumar, and in this video we'll explore graph of a polynomial. I have a separate video to discuss characteristics, but here we'll just see the outline of a graph for a polynomial function. Now in general, a polynomial function in standard form, one variable is given in the form shown here, where a is a real number, the coefficients, and the exponents n are whole numbers. Now, graph of a polynomial will always be a continuous function with no restriction on domain. So there are a few characteristics which are very typical about a graph of a polynomial, and let's write them down first. So one is that it will be x belongs to real numbers. That means in the domain, so x belongs to real number is domain of a polynomial function. There is no restriction, no asymptotes, no vertical asymptotes, no holes and things like that, no discontinuities in any form, right? Then smooth curve. And then, except for one exception, we'll talk about a constant function, but otherwise, as far as the range is concerned, this is about the domain. Range is of two types. If it is an odd degree, in that case, range is all real numbers. Y belongs to real numbers. But if it is even degree, then we may have upper bound or lower bound. One side, not both sides, if it is even degree, right? So what I'm trying to say here is, if it is an odd degree polynomial, you will see a graph which is kind of like this. But if it is even degree, you may have a graph kind of like this, right? Or kind of like this. So it has a local minimum, or absolute minimum I should say, or absolute maximum as far as the range is concerned, right? Another important characteristics in any polynomial is that it will not have these things. Not have, let me list in red, not have corners or a cusp or discontinuity, right? Corners is like this, cusp is kind of like this. Discontinuity, you understand, it could be a hole or it could be a vertical asymptote, right? So it will not have these characteristics in the graph of a polynomial, right? So that is how we can see a polynomial, right? Now let us sketch few polynomials and see what a graph of a polynomial will look like. So there is one exception to most of the rules of polynomial, which is a constant function a0, right? So if I have f of x equals to 1, let's make a graph of it. Can you tell me the equation of this polynomial? X-axis. The function which represents x-axis is a constant function, f of x equals to 0. So the y value is always 0. That is what it is. Okay. Now we could have any other constant value also. For example, we could have like this, where the value is pi. So 3.14 approximately. Or we could have a function which is kind of like this, where let us say the value is minus 2. Right. So likewise, we can have a constant function. Now there is no restriction on domain of this function, but range is very much restricted. Range is just one value. So this function is kind of restricted polynomial, the only exception to the rules which we have been talking about. All other functions, now if you have a linear function, right? So what we talked about is a constant function. So constant function has the restriction, the range is just one number, right? But all other polynomials, range is either bound on one side or it is not bound. So I think that should help you to understand the concept, right? So I've already given you a graph of a constant function. Now let me sketch graph of other kinds of functions, right? So we'll just put them here at the end. So that will give you a fairly good idea of how a polynomial should look like. So if I have a linear function, so linear functions could be like this, correct? So that is a linear polynomial. So if the leading coefficients are positive, let me draw in red first. If they are positive, then they will look like this. So this one is linear. Then you know quadratic, right? Cubic, quartic. Let me write quintic, and so on, right? So a quadratic with positive leading coefficient will be kind of like this. So here we have a lower bound. You see, that is what we mean in the range. Cubic function could be like this. Quartic could be like this. Smooth curve. Quintic, it will start from here and they will end on that side, right? Well, it could go like this. You will notice that odd degree functions, ends are on the opposite ends. These are all odd degree, 1, 3, 5, right? Let me write down their degrees here very clearly. So their degrees is 1, here it is 2, 3, 4, and 5. You will notice that the even degrees face on the same side, but the odd degrees opposite ends. Most important thing which you see is, if the leading coefficient is positive, right side up. When I say right side up, they are all ending up in quadrant 1. We'll explore these more details in characteristics 3.2. So this is when the leading coefficient is positive. This is when a is greater than 0. Now let me sketch those where a is less than 0. That means negative slope, right? So this comes like this when negative slope, right? So that is like y equals to minus x plus 1, let us say, since I moved it up, right? If leading coefficient is negative, this graph will be kind of like this. Here it will be kind of like this. In this case, it may be like this. Okay, in this case, it will start in quadrant 4, right? And then it will be kind of like this. Do you see that? So, right side is not up when leading coefficient is negative, right side is down. And for odd, opposite ends, even, same ends. So that is how the graph of a polynomial is going to look like, right? In the next video, we will see how graph of functions which are not polynomials will look like, right? Have a good look at it and understand. A polynomial should have no restrictions on the domain. It should be a smooth curve. Range is not restricted. For the odd degree functions, it has upper or lower bound for even degree functions. A constant polynomial, however, is an exception to the rule where range is just one number, right? And polynomials are graphs without any corners, cusp, or discontinuity. With this, I think you have fairly good knowledge about graph of a polynomial. Now let us see some graphs of functions which are not polynomial. Okay, thank you.